Today we're talking about Chapter 1, Section 3, Problem Solving with Real Numbers. So, solving word problems, and I know it's going to seem kind of, I'm not going to say cliche or nothing, but I mean, I'm just going to say it. I think word problems are the best way to go about solving math problems, are the best type of math problems as well. Mainly because you can actually see why the material you learn is actually useful, and you actually have to kind of think a lot more about the word problems as opposed to just having a problem and just doing the mindless computation behind it. So I've heard many students be like, when am I ever going to use this? Well, you use it all the time, right? And we're gonna see why here. So we're gonna talk about the basic strategy of solving a word problem, and I can't remember if I've said this to this class or not. I teach 7 classes, so I forget what all I say with all my classes. But um, there's a method to doing word problems, and the thing is, this strategy. Ooh, that's not good. This strategy that is posed to us from the textbook. All right, I'm pretty sure it works. All right, like as I mentioned before, I feel like the authors of the textbook, they know what they're talking about. I think they're smarter than I am about this stuff. But if I were to ask you to write down how to make a peanut butter and jelly sandwich, you would probably just be like, you just do it, right? And that's kind of how word problems are. You just kind of do it. But we will kind of go we will go over this, and I'll give you my uh, the way I think about problems as I go through it. So I'll just kind of say it out loud, just so you can kind of follow along with someone who's done this for quite a while, right? So the best strategy for solving word problems, we're going to read the problem carefully. That seems pretty easy, right? We can read it. We're going to set up, draw any type of figure or diagram that might be helpful, and decide what operations are needed. Then we're going to solve the problem. Then we're going to check the problem. Okay, so I mean, to be honest with you, that's kind of this strategy thing is kind of useless. I mean, you do that anyways, right? You do that with everything. You do that when you post something on Facebook, right? Um, don't tell the authors I said that. But anyways, let's go ahead. Example one. Marianne is finalizing her spring break plans. First, she plans to visit her grandma, who lives 288 miles away. Then, she plans to drive 145 miles to the beach and spend a couple of days with her boyfriend before driving 203 miles home. How many total miles will Marianne drive on her spring break road trip? Okay, well, we're wanting to know how many total miles she drives, right? So, I mean, for the first stop, she goes to visit grandma, then she goes to the beach, then she visits her boyfriend. This seems pretty cut and dry. So she drives 288 miles, plus she drives 145 miles, plus she drives 203 miles. Okay, so in total, she drives, bust out the calculator, 636 miles. So in total, she drives 636 miles. That seems pretty easy, cut and dry. So example 2, 256 should be what I get. I say that because instead of having to, well, never mind. I just want to make sure. All right, so here we go. The owner of a semi-pro baseball team orders baseball from the manufacturers at the beginning of the season. The team is scheduled to play 32 games, and they anticipate using 8 new balls each game. How many baseballs should the owner buy? Okay, so if they plan to use 8 baseballs each game, and there are 32 games, right? Well, it seems very obvious. We're going to do 32 games times 8 baseballs, okay? And that should be 256 baseballs. Right? So we just had to kind of think that one a little bit through, right? 32 games, 8 baseballs each time, and that's how we arrive at 256. Ooh, now we got division. So application dividing whole numbers. One moment. Okay, so dividing whole numbers. 18 friends and neighbors decided to buy tickets to a basketball game with the LA Lakers playing the Boston Celtics. Because they were buying a large number of tickets, they got a special group price of $1,543.50. If they decided to divide the amount equally, what did each of them pay for the ticket? Okay, well, their total was $1,543.50. That was their total. And there were 18 of them, right? So there were 18 of them, so we're going to divide by 18. So 1543 and 50 cents divided by 18 is $85.75. So they 85.75. I'm not entirely sure what basketball tickets go for, but for a Lakers Celtics game, that seems like a steal. Oh, this one looked kind of long, huh? Let me see. Maybe not. Okay. So, from the top, Mr. Lucan bought a used car for $8,000. Taxes of $640 and a license fee of $320 were added to the purchase price. He made a down payment of $2,000 and financed the rest through a credit union. What was the amount of his loan from this credit union? Okay, so this seems pretty easy. So he bought the car for $8,000. He bought the car for $8,000. He paid $640 in taxes and license fee of $320. He made a down payment of $2,000. Okay, so minus 2,000. And then he financed the rest. So let's do this math here. So 8,000 plus 640 plus 320 minus 2,000 is going to be $6,960. So Mr. Lucan financed $6,960 $60 on a used car. That wasn't as bad as I thought it'd be. Bouncing a checkbook. You know, my friends, they, well, obviously, everybody hates math, right? Um, but my friends say, I wish they would have taught us something useful in high school, uh, how to balance our checkbooks or something like that. And I told them, I was like, look, man, it's really not that difficult, right? Not just balancing checkbooks, but you know, doing your own accounting. And here's how it's not so difficult. Don't spend more than you make. All right, I'm off my soapbox now. Just saying, don't spend more than you make, and then you should be all right for the most part. All right, now I understand that there are extenuating circumstances. I was just kind of saying that in jest, especially during this time. So in hindsight, I probably shouldn't have said that. Hopefully, I didn't offend anybody. I was just kind of joking around. Um, sorry. Let's continue. Example 5. Application. Balancing a checking account. So in January, Kathleen opened a checking account and deposited $2,500. During the month, she made another deposit of $1,800 and made debit card purchases of $132.50, $425, $196.25, and $350. What was the balance in her account at the end of the month? Okay, well, we can do some quick math really quickly here, right? So if she opened a checking account and deposited 2,500, and then she deposited 800 more, she had $3,300 in her account. Okay, well, throughout the month, she made debit card purchases of $132.50, $425. I'm running out of room. Let's see. What can we do? Well, $196.25. 9, 6, 25. Right, a little bit smaller now. Let's move everything to the left here. No, that's not what I wanted. Oh, come back 3. There we go. That'll fit now. And she also spent $350. So she is a big spender. Right. So what was the balance of her account at the end of the month? Well, let's do 3,300 minus 132.50. Oops, no, that did plus 50. So 132.50 minus 425 minus 196.25 minus 350. So in her account, she has at the end of the month $2,196.25. Yep, that's a pretty healthy checking account, I think. Okay, so here we go. So a topic closely related to addition and division with whole numbers is the average, also called arithmetic average or the mean of a set of numbers. Your grade in this course may be based on the average of your exam scores. Yeah, obviously, right? Newspapers and magazines report average income, average life expectancy, average sales, average attendance at sporting events, and so on. And the average of a set of numbers is one representation of the concept of the middle of the set. It may or may not actually be one of the numbers in the set. Well, I have a friend. He always likes to say may or may not. And those are literally the only two options, aren't they? May or may not. Anyways, so to find the average of a set of numbers, find the sum of the given set of numbers. Divide this number by the number of numbers in the set. This quotient is called the average of the given set. So what we have to do is we have to find the sum of all the numbers that are given, and then divide by how many numbers there are. Okay. So example 6 reads, find the average of the following set of numbers. Okay. So let's go ahead and do 15 plus 8 plus 90 plus 35 plus 27. Okay, that's going to equal to, probably might have ran out of room there. 15 plus 8 plus 90 plus 35 plus 27, 175. So let's do the thing again where I move it to the left a little bit. There we go. So it's 175. Okay. So what we're going to do is we're going to take that 175 and divide it by, this is one number, two numbers, three numbers, four numbers, five numbers. We're going to take 175 and divide it by 5. Okay, and 175 divided by 5, 175 divided by 5, well, that's going to be equal to 35. So 35 is the average of those 5 numbers. Let's look at some bar graphs here. So, Top-Notch Sporting Goods recorded its profit for tennis rackets for 6 months. The following bar graph indicates the profits for each of the months from January to June. So A, what month had the highest profit? Well, looks like February. Okay. What month had the lowest profit? Looks like April. And what is the average monthly profit over the 6 months? So these are all in the thousands. I'm going to not write it out this time. Instead, here's what I'm going to do. All right, so it wants to know the average monthly profit. So if you recall from the previous example, what I need to do is I need to add up all of these numbers, add up all those numbers, and then divide by 1, 2, 3, 4, 5, 6. So I'm going to add up all those numbers and divide by 6. Give me a second. Okay, so it's 36,000, and then I divide 36,000 by 6, I said. So the average is 6,000, okay? So the average monthly profit here is 6. Let's fix that a little bit. $6,000. Sorry, my stylus is okay. All right, so that's example 7. And example 8. So application, another calculating of average. Um, looks like the same thing there. And this we'll snip this. Alrighty, so on an English exam, 2 students score 95. Okay, so this could get kind of crazy. So looking at this, it says 2 students scored 95, 5 scored 86, 1 scored 82, 1 scored 78, and 6 scored 75. So what I'm going to do is I'm going to say that 2 students, oh no, yeah, so my stylus, so okay, there we go. 2 students, right, scored a 95 plus 5 students scored an 86 plus 1 student scored an 82, 1 scored a 78, and 6 scored a 75. So plus 6 scored a 75. What was the average score for the class, right? So I'm just going to do the arithmetic here, right? So 2 times 95 is 190. So 190 no. And my stylus ain't, there we go. 100. Not good. So there we'll flip pen upside down. So 190 plus 5 times 86. So 5 times 80 is 400, and then 6 times 5 is 30, so 430 plus 82 plus 78 plus 6 times 7 is 42 times 5 is 450. I'm sorry, 450. Okay. I'm going to add all those up. So let's add all those up real fast. Okay, so 1230. 1230, right? Well, now we have to divide it by the number of tests, okay? So it's not 1, 2, let's see, it's not 1, 2, 3, 4, 5, and it's not 5 numbers, right? It is, we had 2 students score 95, 5 scored 86, 1 scored 82, 1 scored 78, and 6 scored 75. So essentially, 2 plus 5 is 7, plus 1 is 8, plus 1 is 9, plus 6 is 15. So there's those 15 students that took the test, right? So it's 1230 divided by 15, which is, not times 15, divided by 15, is 82. So the, divided by 15 is 82, right? That is the average test score in this particular class, right? And that concludes Chapter 1, Section 3.